Hello everyone and welcome to the channel. If you're preparing for your FAA Airframe Mechanic Knowledge exam, you're in the right place. In this series, I'll be reading questions from the ASA Airframe Test Guide, followed by the answer and the explanation to help you understand the material and not just memorize it. The information covered in these videos is based on the current edition of the ASA Airframe Test Guide and the FAA references used throughout A&P training, including the Aviation Mechanic Airframe Certification Standards, or ACS, and the FAA Aviation Maintenance Handbooks, such as the Airframe 8083-31B and the 8083-32B for the power plant, airframe, and generals. Oh yeah, as well as the AC 4313. My goal of these videos is to provide a simple, up-to-date study resource for students working toward their airframe, power plant, and ultimately their A&P certification. So, to start, in the Airframe 8083, today's video will be covered with Chapter 4, Aviation Metal Structural Repair. And in the ASA Test Guide, we'll be covering metallic structures, starting at page 1 and ending on, I think it's page 13, that the welding stuff, did I stop? Yeah, page 13, or no, page 12, sorry. We'll be stopping on question 8103. So, without further ado, let's get started on these questions. So again, that's page 1 of the ASA Test Guide that I'll be starting with. And the first question is 8107. Which statement is true regarding the inspection of a stressed skin metal wing assembly known to have been critically loaded? If genuine rivet tipping has occurred, groups of consecutive rivet heads will be tipped in the same direction. The explanation is, if the structure has actually been damaged, this would be indicated by groups of consecutive rivet heads being tipped in the same direction caused by a major deflection of the skin under load. The next question is 8061. What precaution, if any, should be taken to prevent corrosion inside a repaired metal honeycomb structure? Prime the repair with a corrosion inhibitor and seal from the atmosphere. And the explanation for that one is, when a repair to a metal honeycomb structure is made, the repair should be primed with a corrosion inhibiting primer and should be sealed so no moisture or air can get to the inside of the repair. Next question is 8114. When repairing a small hole on a metal stressed skin, the major consideration in the design of the patch should be the shear strength of the riveted joint. And the explanation for that one is, when repairing a small hole in metal stressed skin, the rivet should take all the stress from the skin and carry it into the patch. On the opposite side of the damage, this stress is carried back into the skin. The shear strength of the riveted joints should be slightly less than the bearing strength of the skin. If a failure should occur, it will be a shear failure of the rivets, rather than a bearing failure of the skin. Next question is 8116. Repairs or splices involving stringers on the lower surface of stressed skin metal wings are usually permitted, but are normally more critical in reference to strength and tension than similar repairs to the upper surface. And the explanation for that one is, repairs or splices to the stringers on the lower surface of a stressed skin metal wing are permitted, but since the lower surface of the wing is under tensile load in flight, these repairs are more critical with regard to tensile strength than repairs to the upper surface. Next question is 8118. Clad aluminum alloys are used in aircraft because they have surface layers of pure aluminum or aluminum alloy bonded to the core material to inhibit corrosion. The explanation for that one is clad aluminum alloys are used in aircraft construction because they are less subject to corrosion than uncoated aluminum alloys. Pure aluminum, which is not susceptible to corrosion, is used to coat a sheet of high-strength aluminum alloy to protect it from corrosion. And the next question is 8120. Aircraft structural units such as spars, engine supports, etc., which have been built up from sheet metal, are normally repairable using approved methods. And the explanation for that one is aircraft structural units which are built up from sheet metal are normally repairable using procedures recommended by the manufacturer of the airframe and approved by the FAA. And next question is 8123. Parts fabricated from Alclad 2024 T3 aluminum sheet stock must have all scratches, kinks, tool marks, nicks, etc. held to a minimum. And the explanation for that one is when fabricating parts from Alclad 2024 T3 aluminum sheet stock, be sure that all damage such as scratches, kinks, tool marks, and nicks are held to a minimum to prevent exposing the alloy core through the damaged pure aluminum surface coating. The next question is 8161. If a streamlined cover plate is to be hand-formed using a form block, a piece of dead soft aluminum should first be placed over the hollow portion of the mold and securely fastened in place. The bumping operation should be started by tapping the aluminum lightly around the edges and gradually working down into the center. The explanation for that one is when using the bumping operation to form a compound curve in a piece of soft aluminum, the light blows of the mallet to work the material down gradually from the edges. Remember that the object of the bumping process is to work the material into shape by stretching it, rather than by forcing it into the form with heavy blows. Always start bumping near the edge of the form. Never start in the center. Always on the edge, never in the center. Next question is 8170. You can distinguish between aluminum... Oh, sorry. Let me restart that. You can distinguish between aluminum and aluminum alloy by testing with a 10% solution of caustic soda. The explanation for that one is aluminum alloys of the 2XXX series, or 2 series basically, can be identified by using a 10% solution of caustic soda. When this solution is applied to the material, it reacts with the copper in the alloy and forms a dark spot. The next question, 8058. When repairing punctured type damage to metal-faced laminated honeycomb panel, the edges of the doubler should be tapered to 100 times the thickness of the metal. The The explanation for that one is when repairing puncture type damage to a metal-faced laminated honeycomb panel, cut a piece of aluminum alloy the same thickness or thicker than the original face, and taper the edges of this patch to a ratio of about 100 to 1. Next question is 8112. Which is correct concerning the use of a file? Apply pressure on the forward stroke only, except when filing very soft metals such as lead or aluminum. The explanation for that one is to prevent undue wear of the file. When filing any metal other than lead or soft aluminum, apply pressure only during the forward stroke. Relieve the pressure during the return stroke. The next question is 8115. Which procedure is correct when using a reamer to finish a drilled hole to the correct size? Turn the reamer only in the cutting direction. The explanation for that one is, when using a reamer to enlarge a hole, always turn the reamer in the direction of cutting. If the direction of reamer motion is reversed, the reamer will be seriously dulled. Next question is 8117. When straightening members made of 2024 T4, you should straighten cold and reinforce. The explanation to that one is, if a structure member made of 2024 T4 aluminum alloy is bent, it should be straightened cold and then reinforced. Basically the same thing as the answer. Next question is 8138. The primary alloying agent of 2024 T3 aluminum alloy is indicated by the number 2. The explanation for that one is, the primary alloying agent in 2024 T36 aluminum alloy is copper, which is identified by the first digit 2. Next question is 8139. Which part of the 2017 T36 aluminum alloy designation indicates the primary alloying agent used in its manufacture? 2. The primary alloying agent in 2017 T36 aluminum alloy is copper, which is identified by the digit 2. Next question is 8175. The sight line on a sheet metal flat layout can be bent in a cornice or box break. Let me restart that. The sight line on a sheet metal flat layout to be bent in a cornice or box break is measured and marked 1 radius from the bend tangent line that is placed under the break. And the explanation for that one is, when making a bend in a piece of sheet metal in a cornice or box break, draw a sight line inside the bend allowance that is 1 bend radius from the bend tangent line that is placed under the break. Sight down vertically over the edge of the radius bar and place this sight line directly in line with the edge of the radius bar. In this position, the bend tangent line is at the beginning of the radius. Next question is 8042. A main difference between lock bolt / hook bolt tension and shear fasteners, other than their application, is the number of locking collar grooves. The explanation for that one is a lock bolt has locking grooves in its pin into which the collar is swaged. A shear lock bolt has 2 locking grooves, and the tension lock bolt has 5 grooves. The next question is 8044. The general rule for finding proper rivet diameter is 3 times the thickness of the thickest sheet. And the explanation for that one is a rule of thumb for determining the rivet diameter to be used for repairing aircraft sheet metal is to use a rivet whose diameter is approximately 3 times the thickness of the thickest sheet being joined. The next question is 8045. The shop head of a rivet should be 1 1/2 times the diameter of the rivet shank. The explanation for that one is the shop or bucked head of a rivet should have a diameter of 1 1/2 times the rivet shank diameter and a thickness of half of the shank diameter. Next question is 8046. One of the main advantages of high lock type fasteners over earlier generations is that they can be installed with ordinary hand tools. The explanation for that is high lock fasteners are a new form of high shear fasteners that can be installed with ordinary hand tools rather than requiring the special riveting tools. The pin is installed in an interference fit hole and the collar screwed down over the threaded end. The pin is held with an Allen wrench and the collar is screwed down. Using an open end wrench until the proper torque is reached. At this point, the hex shear nut portion of the collar will break off. The next question is 8046-1. Which of the following is one advantage of high lock fasteners? Inability to be over-torqued. And the explanation for that one is the advantages of a high lock 2-piece fastener include its lightweight, high fatigue resistance, high strength, and its inability to be over-torqued. Second, let me turn to the next page. Come on. The next question is 8047. The markings on the head of a Zeus fastener identify the body diameter, type of head, and length of the fastener. And the explanation for that one is Zeus fasteners are identified by marks on the head of the stud. A letter identifies the type of head, a number identifies the body diameter in 1/16 inch increments, and another number identifies the stud length in hundredths of an inch. Remember that body diameter is 16 inch increments, and the length is hundredths of an inch. That seems to be a recurring question in the exams, from what I've noticed. Next question is 8048. The Zeus turnlock fastener consists of a stud, grommet, and receptacle. The stud length is measured in hundredths of an inch. And the explanation for that is the stud length of a Zeus fastener is measured in 100th inch increments. It seems to be a recurring question, so that's why I said take note of that one. Next question, 8049. The Zeus turnlock fastener consists of a stud, grommet, and receptacle. The stud diameter is measured in 1/16 of an inch. Like I said, very recurring. The explanation is simply the diameter of the stud of a Zeus fastener is measured in 1/16 inch increments. So yeah, they're like three of the same questions. The only difference is the stud length and the stud diameter, and then the one is just identifying the markings on the head of a Zeus fastener. Next question is 8050. Threaded rivets, or riv nuts, are commonly used to attach parts or components with screws to sheet metal. The explanation for that one is riv nuts are a special type of blind rivet whose shank has the internal threads. When the riv nut is upset in a piece of thin sheet metal, the threaded rivet shank acts as a nut to receive a machine screw. Riv nuts were originally designed to attach de-icer boots to thin sheet metal wing and empennage leading edges. Next question is 8100. Select the alternative which best describes the function of the flute section of a twist drill. It forms the cutting edges of the drill point. And the explanation for that one is one of the functions of the flute, or of the flutes cut into the shank of a twist drill, is to form the cutting edges of the drill point. Now we're kind of getting into math questions. 8101. How many MS 2470 AD-4-6 rivets will be required to attach a 10-inch by 5-inch plate using a single row of rivets, minimum edge distance, and 4D spacing? $56. The explanation for that one is the plate is 10 inches long and 5 inches wide. The rivets have a diameter of 1/8 inch, and there is an edge distance of 2 rivet diameters. This requires 2 rows of rivets 9.5 inches long and 2 rows that are 4.5 inches long. The total length of the rivet seams is 28 inches. If the rivets are spaced every half inch, or 40 spacing, 56 rivets will be needed. And for future math questions, I suggest pausing this video and actually trying to solve the answer rather than just knowing it. Repetition makes people great. The next question is 8104. What should be the included angle of a twist drill for soft metals? $90. The explanation for that one is, for drilling soft metals, an included angle of about 90 degrees or 45 degrees either side of center is suitable. For normal metals, an angle of 118 degrees or 59 degrees on either side of center is considered the standard lip angle. Next question is 8105. When comparing the machining techniques for stainless steel sheet metal material to those for aluminum alloy sheet, it is normally considered good practice to drill the stainless steel at a lower speed with more pressure applied to the drill. And the explanation for that is, when drilling stainless steel, you should use a drill with a larger included angle. Use a lower speed and more pressure than you would use for aluminum alloy. Next question is 8106. This is another math question, so I would pause the video and, get a notebook, calculator, whatever you need. A single lap sheet splice is to be used to repair a section of damaged aluminum skin. If a double row of 1/8 inch rivets is used, the minimum allowable overlap will be 13/16 of an inch. And the explanation for that one is, the minimum row distance is 2.5 times the diameter. So 4 times the diameter plus 2.5 times the diameter equals your total overlap. So 6.5 times the diameter equals 13. Given the rivet diameter specified in this question, 13/2, or simplified is 1/8 of an inch. I think I completely butchered that question. I'm sorry. That question is 8106. I'm going to have to go back over that one and try to understand it a little bit better. Next question is 8106-1. This is a follow-up question to the previous question. I'm sorry if I confused you. That's one of those I would go back and look at yourself because I just butchered the crap out of that. Follow-up question 8106-1. What is the minimum edge distance allowed for a... What is wrong with me? What is the minimum edge distance allowed for aluminum alloy single lap sheet splices containing a single row of rivets as compared to a joint with multiple rows, all rivets being equal in diameter? The minimum edge distance for the single row is equal to that for the multiple row. And the explanation for that one is, the minimum edge distance allowed for an aluminum alloy single lap sheet splice is the same whether a single row of rivets or if a multiple row of rivets is used. This distance is 2 times the diameter of the rivet being used. Next question is 8109. When drilling stainless steel, the drill used should have an included angle of 140 degrees and turn at a low speed. The explanation for that one is, the drill used for drilling stainless steel should have a much flatter angle than a drill used for soft material. An included angle of approximately 140 degrees is good for stainless steel. When drilling stainless steel, the drill should turn at a slow speed. Next question is 8122. What should be the included angle of a twist drill for hard metal? (118 degrees). The explanation for that one is, for most drilling, including that for hard metal, the cutting angle of a twist drill is ground to an included angle of 118 degrees or 59 degrees on either side of center. And the next question is 8126. Rivet gauge, or transverse pitch, is the distance between the centers of rivets in adjacent rows. The explanation for that is, rivet gauge, or transverse pitch, is the distance between the centers of rivets in adjacent rows. Next question is 8127. Rivet pitch is the distance between the centers of adjacent rivets in the same row. Next question is 8128. This question I would refer to your own test guide, or if you don't have the test guide, I'm sure you can find something on Google. I'm on page 5, question 8128. Refer to figure 2. Select the preferred drawing for proper countersinking. The answer they have for me is 1. It might be different for other test guides, I'm not entirely sure, I doubt it is, but my test guide says it's 1. The explanation for this one is, the type of countersinking shown in view 1 is preferred. The type of countersinking showed in view 2 is acceptable, and the type of countersinking showed in view 3 is not acceptable. Next question is 8129. What is indicated by a black, smoky residue streaming back from some of the rivets on an aircraft? Fretting corrosion is occurring between the rivets and the skin. A smoky explanation. A smoky residue streaming back from some of the rivets in an aircraft structure is normally an indication of fretting corrosion. An extremely small amount of relative movement between the rivet and the skin allows the oxide to be rubbed off the rivet and the surface of the rivet hole. It acts as an abrasive, wearing off more oxides. These loosened oxides work their way out between the skin and the rivet and resemble smoke streaming out of the rivet. The next question is 8130. The identifying marks on the heads of aluminum alloy rivets indicate the specific alloy used in the manufacture of the rivets. The explanation for that one is, the identifying mark on the head of aluminum alloy rivets indicates the specific alloy used in the manufacture of the rivet. Next question is 8131. When an MS-2470D rivet is installed, its full shear strength is obtained only after a period of age hardening. And the explanation for that one is an MS-2470D rivet is an, quote, icebox rivet, unquote. And it must be heat treated before it is driven. After it is removed from the quench bath, it is stored in a sub-freezing refrigerator to keep it soft until it is ready to be driven. After it is driven, it age hardens. It regains approximately half its strength in 1 hour and its full strength in 4 days. Next question is 8134. Under certain conditions, Type A rivets are not used because of their low strength characteristics. Explanation. Type A rivets, commercially pure aluminum rivets, are not used for aircraft structural repair because of their low strength characteristics. Next question is 8135. A rivet set used to drive MS-2470 rivets should have a slightly greater radius than the rivet head. The explanation for that is the rivet set used to drive AN-470 or MS-2470 universal head rivets should have a radius slightly larger than the radius of the rivet head. This larger radius allows the hammering action of the rivet gun to be directly on the crown of the rivet. Question 8137. The dimensions of an MS-2430 AD4-8 rivet are 1/8 inch in diameter and 1/2 inch long. The explanation is the first dash number in the rivet identification gives the rivet diameter in 1/32 inch increments. The second dash number gives the rivet length in 1/16 inch increments. An MS-2430 AD4-8 rivet is 4/32 of an inch, or simplified 1/8 of an inch, in diameter and 8/16 of an inch, or 1/2 inch long. Next question is 8138-1. Which part of a 2017 T36 aluminum alloy indicates the temper designation? T36. The explanation is to provide a visual means for identifying the various grades of aluminum and aluminum alloys. Aluminum stock is usually marked with symbols such as a government specification number, the temper or condition furnished, or the commercial code marking. The commercial code markings consist of number that identifies the particular composition of the alloy. Additionally, letter suffixes designate the basic temper designations and subdivisions of aluminum alloys. Next question is 8140. This one's a little bit of math, so a sheet metal repair is to be made using 2 pieces of 0.040 inch aluminum riveted together. All rivet holes are drilled for 3/32 inch rivets. The length of the rivets to be used will be 1/4 inch. The explanation for this one is this problem calls for joining 2 pieces of 040 inch material using 3/32 inch rivets. The total thickness of the material is 80 thousandths of an inch. The rivet should protrude through the material for 1 1/2 diameters, or 0.1406, or in fraction 9/64 of an inch. The total length of the rivet must be .080 plus 0.1406 or 0.2206 inches. The nearest standard rivet to this length is 1/4 inch long or 0.250. Next question is 8141. Most rivets used in aircraft construction have dimples. Explanation: most rivets used in aircraft construction and repair are made of aluminum alloy 2117. 2117 rivets are identified by a dimple in the center of the manufactured head. Next question is 8142. MS 2426 AD 6-5 indicates a countersunk rivet which has an overall length of 5/16 of an inch. The explanation is an MS 2426 AD 6-5 rivet is a countersunk head rivet made of 2117 aluminum alloy. It has a diameter of 6/32 of an inch, or simplified 3/16 of an inch, and an overall length, including the head, of 5/16 of an inch. So countersunk heads are the top of the head of the rivet to the bottom of the shank. Next question is 8144. Refer to figure 3. Which is the grip length of the flush rivet? Pause it if you need to. The answer they give is 3. And the explanation is the grip length of a rivet is the total thickness of the material held together by the rivet. In this question, the grip length is dimension 3. Question 8145. Which rivets should be selected to join two sheets of 0.032 inch aluminum? MS 2470 AD 4-4. The explanation is the two pieces of material to be joined have a total thickness of 0.064 inches. The rivet used with this metal should have a diameter of about 3 times the thickness of the thickest sheet. This would cause us to choose a rivet with a diameter of 3 times 0.032 inches or 0.096 inches. The closest rivet to this one, with a diameter of 1/8 inch or 0.125 inch. A 1/8 inch rivet should extend through the material for 3/16 of an inch or 0.1875 inch. The total length of the rivet must be 0.064 plus 0.1875 or 0.2515 inch. We would choose an MS 2470 AD 4-4 rivet. This is a universal head rivet, 1/8 inch in diameter and 1/4 inch long. Next question is 8146. We got a lot more math. A sheet metal repair is to be made using two pieces of 0.0625 inch aluminum riveted together. All rivet holes are drilled for 1/8 inch rivets. The length of the rivets to be used will be 5/16 of an inch. And the explanation for that is each of the two sheets of material to be riveted together has a thickness of 0.0625 inch. The total thickness of the material is 0.125 inch, and the 1/8 inch rivets should be extended through the material for 1 1/2 diameters, which is 0.1875 inch. The total length of the rivet must be 0.3125 inch, which is 5/16 of an inch. Next question is 8147. Mild steel rivets are used for riveting steel parts. The explanation says mild steel rivets are used for joining steel parts. Next question is 8149. When riveting dissimilar metals together, what precautions must be taken to prevent an electrolytic action? Place a protective separator between areas of potential electrical differences. And their explanation is one precaution to be observed when riveting together dissimilar metals is to place a non-conductive separator between the two surfaces. This separator prevents the migration of electrons between the areas of the electrode potential difference. Next question is 8150. The length of a rivet to be used to join a sheet of 0.032 inch and 0.64 inch aluminum alloy should be equal to 1 1/2 times the diameter plus 0.096 inch. And the explanation for that one is the rivet length used to join two sheets of metal should be equal to the total thickness of the metal being joined, plus 1 1/2 times the diameter of the rivet. The total thickness of the materials being joined is 0.096 of an inch. The length of the rivet should be 1 1/2 times the rivet diameter plus 0.096 inch. Question 8154. Which rivet is used for riveting magnesium alloy structures? (5056) aluminum. And their explanation is to prevent corrosion in a magnesium structure, 5056 aluminum alloy rivets should be used. Magnesium is the chief alloying agent in 5056 aluminum alloy. Next question is 8155. Which rivet is used for riveting nickel steel alloys? Monel. And their explanation is Monel rivets are used for riveting nickel steel alloys. Next question is 8156. The length of a rivet to be chosen when making a structural repair that involves the joining of 0.032 inch and 0.064 inch aluminum sheet drilled with a number 30 drill is 5/16 of an inch. And their explanation is the two sheets of material to be riveted together have a total thickness of 0.096 inch. The rivet installed in a number 30 hole is a 1/8 inch rivet. It should extend through the material a distance of 0.1875 inch. The total length of the rivet must be 0.096 plus 0.1875, which should equal 0.2835. The nearest standard rivet length to this is a 5/16 inch, or in decimal form, it's 0.3125. And to convert fractions to decimals, you just take the numerator and divide it by the denominator, and it should give you your decimal. If not, there's other YouTube videos on how to turn fractions into decimals, if you don't know how to do it. Moving on, next question is 8157. I'd pause the video for this one because it refers to figure 4, and it asks, the length of flat A is 3.750 inches. And their explanation is, the length of flat A is its mold line length of 4.00 inches minus the setback. The setback is the metal thickness, or 0.0625 inch, plus the bend radius, which is 0.1875 inch, or 0.250 inch. So the length of flat A is 4 minus 0.250, which should equal 3.750 inches. Next question is 8158. Again, refer to figure 4. The amount of material required to make the 90-degree bend is 0.3436 inches. And their explanation is, using the formula in figure 4, like I said, you should have the book open for these. Using the formula in figure 4, we find the total amount of material needed to make the bend is 0.3434 inch. Bend allowance equals 2 pi parenthesis r plus half the thickness in parenthesis, all divided by 4. And then they go on to solve this equation by solving 2 pi, which is 6.28 parenthesis, and your radius of 0.1875 plus half the thickness, which should equal 0.03125 parenthesis, divided by 4. And they solve the top portion, which comes to 1.3737 divided by 4. And after solving that, you should get 0.3434. And none of their answers actually equal the answer on the question. It's just the answer to 8158 is 0.3436, and their final answer was 0.3434. So I guess you would just have to round. Whatever decimal that is, just round up. Sorry if that was confusing. Moving on to the next question. 8159. Refer to figure 5. What is the length of flat A? .7 inches. And their explanation is, the length of flat A is its mold line length of 4 inches minus the setback. The setback is the metal thickness, 0.062 inch, plus the bend radius, 0.250 inch, or 0.312 inch. The length of flat A is 4 inches minus 0.312, which should equal 3.688 inches. And I guess that one you would also round up, because the answer is 3.7, but they get a smaller decimal, so. Next question, 8162. A piece of flat stock that is to be bent to a closed angle of 15 degrees must be bent through an angle of 165 degrees. And their explanation is, a closed angle is an angle that has been bent beyond 90 degrees. In order to form a closed angle of 15 degrees, the sheet must be bent through an angle of 165 degrees. And then they have parenthesis 180 degrees being a flat layout piece of sheet metal minus your 15 degrees, and that comes to 165 degrees. Next question is 8163. When a piece of aluminum alloy is to be bent using a minimum radius for the type and thickness of material, The layout should be made so that the bend will be 90 degrees to the grain of the sheet. And their explanation is, for the greatest strength in a bent piece of material, the layout should always be made so that the bend will be perpendicular to the grain of the sheet. Always bend your sheets of metal to perpendicular to the grain of the metal. And the best way to tell that, from what my teacher told me at A&P school, is that the letters that are stamped on the metal run parallel to the grain. So make sure to pay attention to that. Next question is 8164. The flat layout or blank length of a piece of metal from which an L-shaped bracket 3 inches by 1 inch is to be bent depends upon the radius of the desired bend. The bracket which will require the greatest amount of material is one which has a bend radius of 1/8 of an inch. And their explanation for that one is, the larger the bend radius in this L-shaped bracket, the less material is needed. If we assume the metal thickness is 0.063 inch, the bracket having a 1/8 inch bend radius will need 3.865 inches of material. The bracket having a ½ inch radius will only need 3.704 inches of material. The bracket having a 1/4 inch radius will need 3.811 inches of material. So I guess this one you would have to divide numerator by denominator to get your decimal. Next question is 8165. If it is necessary to compute a bend allowance problem and bend allowance tables are not available, the neutral axis of the bend can be found by adding approximately 1/2 of the stock thickness to the bend radius. And their explanation is, the neutral axis is not the exact center of the thickness of the material or the stock, but for all practical purposes, the neutral axis of a bend can be considered to be the bend radius plus 1/2 of the stock thickness. Next question is 8166. Unless otherwise specified, the radius of the bend is the inside radius of the metal being formed. And their explanation for that one is, the bend radius of a piece of sheet metal is the radius of the inside of the bend. Pretty simple. Next question is 8167. The sharpest bend that can be placed in a piece of metal without critically weakening the part is called the minimum radius of bend. And their explanation is, the minimum radius of bend, or as it is more commonly called, the minimum bend radius, is the sharpest bend that can be made in a piece of metal without critically weakening the part. Next question is 8169. A piece of sheet metal is bent to a certain radius. The curvature of the bend is referred to as the bend radius. And their explanation is, when a piece of sheet metal is bent, the curvature of the inside of the bend is referred to as the bend radius. Next question is 8172. When bending metal, the material on the outside of the curve stretches while the material on the inside of the curve compresses. That part of the material which is not affected by either stress is the neutral line. Their explanation for that one is, The material on the outside of a curve stretches, while the material on the inside of the curve compresses. There is a location near the middle of the metal thickness that neither shrinks nor stretches. This is called the neutral line or the neutral axis of the material. Next question is 8177. On a sheet metal fitting layout with a single bend, allow for stretching by subtracting the setback from both the legs. And their explanation is, when laying out a sheet metal fitting having a single bend, the setback must be subtracted from the mold line length of both of the legs. Next question is 8043. Alloy 2117 rivets are heat treated by the manufacturer and do not require heat treatment before being driven. And their explanation for that one is alloy 2117 rivets, which are called AD rivets, are heat treated by the manufacturer. They do not require any further heat treatment before they are driven. Next question is 8133. What is the purpose of refrigerating 2017 and 2024 aluminum alloy rivets after heat treatment? To retard age hardening. And their explanation for that one is 2017 and 2024 aluminum alloy rivets must be heat treated before they are driven. Immediately after they are quenched, they should be stored in a sub-freezing refrigerator. Storing the rivets at the cold temperature retards their aging process and allows time to elapse between their heat treatment and their being driven. Next question is 8136. Heat treated rivets in the D and DD series that are not driven within the prescribed time after the heat treatment or removal from refrigeration must be reheat treated before use. And their explanation on that one is heat treated rivets of the D or double D series that are not driven within the prescribed time after the heat treatment or which have been removed from the refrigeration must be heat treated again before they are used. There is no specific number of times they may be reheat treated. Next question is 8143. Which rivet may be used as received without further treatment? (2117T3). And their explanation is a 2117 rivet is known as an AD rivet. It may be driven as received without further heat treatment. Next question is 8148. A double D rivet is heat treated before use to soften to facilitate riveting. And their explanation for that one is double D or 2024 T rivets are heat treated before they are driven to soften them so they will not split when they are driven. Next question is 8178. The aluminum alloys used in aircraft construction are usually hardened by which method? Heat treatment. The explanation for that one is alloys used in aircraft sheet metal construction are hardened by heat treatment. Next question is 8041. A well-designed rivet joint will subject the rivets to what kind of loads? shear loads. Their explanation is a properly designed rivet joint has the major part of the load in the rivets as a shear load. Next question is 8108. What is the minimum edge distance for aircraft rivets? Two times the diameter of the rivet shank. And their explanation is the minimum edge distance for aircraft rivets, or the distance between the center of the rivet hole and the edge of the sheet, is twice the diameter of the rivet shank. Next question is 8110. What is the minimum spacing for a single row of aircraft rivets? Three times the diameter of the rivet shank. And their explanation is, rivets in a single row should be spaced no closer than 3 times the diameter of the rivet shank, also known as 3D. Next question is 8121. A factor which determines the minimum space between rivets is the diameter of the rivets being used. And their explanation is, rivet spacing is based on the diameter of the rivet shank. It is expressed in terms of rivet diameters. Next question is 8132. Which of the following need not be considered when determining minimum rivet spacing? Rivet length. And their explanation for that one is, the length of the rivet does not enter into the determination of the minimum rivet spacing. The rivet diameter and the type of thickness of the material do determine rivet spacing. Next question is 8160. Refer to figure 5. This one's math. What is the flat layout dimension? .8 inches. Their explanation for that one is, the dimension of flat A is 3.688 inches. The dimension of flat B is 2.688 inches. Using the bend allowance formula, 2 pi parenthesis the radius plus half the thickness parenthesis all divided by 4. I'm just telling you the bend allowance formula because it helps me too. So once you know the bend allowance formula, you find that 0.41 or 441 inches of material is used to make the bend. The total layout dimension is 3.688 plus 2.688 plus 0.441, which should come to 6.817 inches. I apologize if my explanation of math problems is not that good. I'm not very good at explaining things, which is why I'm reading this stuff word for word. And I suggest you follow along, because it's much easier to understand if you read the explanation and look back at the answer and then try to do it yourself. At least that's what helped me. So moving on to the next question on page 11, 8168. The most important factors needed to make a flat pattern layout are what? The radius, the thickness, and degree of bend. And their explanation for that one is, when making a flat pattern layout, a piece of formed sheet metal, a piece of formed sheet metal, there are 4 things we must consider. Number 1 is the radius of the bend. Number 2 is the thickness of the material being bent. Number 3 is the number of degrees in the bend. And number 4, the lengths of all the flat portions of the part, including the mold line dimension minus the setback. Next question is more math. 8173. Refer to figure 6. Determine the dimensions of A, B, and C in the flat layout. Your setback equals 0.252 and your bend allowance is 0.345. At this point, I hope you would have paused the video to solve the math for yourself. But the answer is A equals 0.74A, B equals 1.496, and C equals 1.248. And their explanation is your setback equals the radius plus the thickness, or 0.188 plus 0.064 equals 0.252 inches. Dimension A is the mold line length of 1 inch, less 1 setback. This gives the length of 0.748 inches. So you would just do 1 inch minus 0.252, which should come to 0.748. For dimension B is the mold line length of 2 inches, less 2 setbacks. This gives a length of 1.496, or in simpler terms, since you have 2 bends in the flat layout, or in the entire part, you have to subtract 2 setbacks from flat or dimension B. So it would be 2 minus 0.504, which should give you 1.496. And then dimension C is the mold line length of 1.5 inches less 1 setback. This gives a length of 1.248 inches, or 1.5 inches minus 0.252 should equal 1.248. I know that was a mouthful, but once you get the hang of doing it, it's easy math. It's just following equations. Once you understand them, it's a lot easier, I promise. And to those of you that do get it, congratulations. And if somebody's commenting they need help with math or something, or, you see people that are struggling, help them. Help a fellow A&P out. Next question is 8174. Refer to figure 6. What is dimension D? Your setback equals 0.252 and your bend allowance equals 0.345. Point 4.182. They already gave you setback and bend allowance, so their explanation is dimension A is a mold line length of 1 inch, less... Sorry, that just threw me off. Dimension A is a mold line length of 1 inch minus the setback, or 0.252, which should give you a length of 0.748. Dimension B is the mold line length of 2 inches minus 2 setbacks. This should give a length of 1.496. Dimension C is the mold line length of 1.5 inches minus 1 setback. This gives a length of 1.248 inches. And then dimension D is the sum of dimensions A, B, and C plus 2 bend allowances. So in this case, you would do 0.748 plus 1.496 plus 1.248 plus 0.345 plus 345. And it should give you a total of 4.182. Next question is 8176. Refer to figure 7. What is dimension F? They give you your setback at D, which equals 0.095, your setback at E equals 0.68, your bend allowance at D equals 0.150, and your bend allowance at E equals 0.112. .936. Flat A is 1 inch minus setback D, which is 0.095 inch. Which, after doing that math, you should get 0.905 inch. Flat B is 3 inches minus setbacks D and E, 0.095 plus 0.068, which should equal 0.163. And then 3 inches minus 0.163 is 2.837 inches. And flat C is 2 inches minus setback E, 0.068 inches, which should equal 1.932 inches. Add to the total length of all three of the flats the amount of material needed to make both of the bends, 0.150 inch for bend D and 0.112 inch for bend E. The total developed length, or length F, is 0.905 plus 2.837 plus 1.932 plus 0.150 plus 0.112, which should equate to 5.936 inches. Like I said, if you're not doing these, you're not going to get it. You have to follow along and do them for yourself. And if you guys need help, I would highly suggest searching for videos, or hell, I could make videos on it. If you guys want to see videos of me trying to teach this math, I'd be more than happy. I am by no means a teacher, but I will do my best to explain how it works, if you want. I don't know if this video is ever going to get far, but we'll see. Next question is 9034. Which of the following statements is true regarding replacement rivets? The new edge distance of larger replacement rivet must not... Oh, hold on, I'm going to restart that answer. The new edge distance of larger replacement rivets must not be less than minimums. And their explanation is, replacement rivets are to be of the same size and same strength whenever possible. If the rivet hole has become enlarged or damaged, the next larger size rivet is used. Edge distance and rivet spacing must be considered and is not allowed to be less than minimums. Rivets may not be replaced by a type having lower strength properties unless the lower strength is adequately compensated with an increase in size or a greater number of rivets. In other words, engineers, they got your back, usually. This next page, we're almost done. Next question is 8051. The installation of Cherry Max and Olympic lock rivets is accomplished by utilizing a pulling tool. Their explanation for that is Cherry Max and Olympic lock rivets are types of blind rivets that are installed by inserting them into the hole and pulling the stem with a special pulling tool. When the stem is pulled, a taper swells the end of the shank and upsets it. Continued pulling breaks the stem off and leaves part of it in the hollow shank to reinforce it. Next question, refer to figure 1. Which of the rivets shown will accurately fit the conical depression made by a 100-degree countersink? The answer they have here is 1. Their explanation is the angle between the head and the shank of rivet 1 is 130 degrees on each side, or 260 degrees on both sides. The angle formed by the rivet head is 100 degrees, and to get that, you do 360 degrees minus 260 degrees, which is the standard angle for the cutter in an aircraft rivet countersink. Next question is 8113. What is one of the determining factors which permits machine countersinking when flush riveting? Thickness of the material is greater than the thickness of the rivet head. Their explanation is, to use machine countersinking for installing a countersunk rivet, the thickness of the material must be greater than the thickness of the rivet head. Next question is 8151. What is generally the best procedure to use when removing a solid shank rivet? Drill to the base of the manufactured rivet head with a drill one size smaller than the rivet shank and remove the rivet with a punch. And their explanation is, when removing a solid shank rivet from a piece of aircraft structure, drill to the base of the manufactured head with a drill one size smaller than the rivet shank. Insert a pin punch into the hole and pry the head off. Then use the pin punch to drive the rivet shank from the skin. So you'll need a hammer to tap it out. Next question is 8152. Joggles in removed rivet shanks would indicate partial what type of failure? Shear failure. I added some extra wording to that question just to kind of spice it up a little bit. But their explanation is, a joggle or offset in the shank of a rivet that has been removed from a damaged aircraft structure indicates that the rivet joint has failed in shear, aka shear failure. The next question is 8153. What type of loads cause the most rivet failures? Just went over this last question. Shear. Their explanation is, a shear load which causes most rivet failures is one that tries to cut a rivet by shearing it. Rivets are designed to be used in joints loaded in shear only. Next question is 8171. The purpose of a joggle is to allow clearance for a sheet or extrusion. Their explanation is, a joggle is an offset bend in the end of a sheet or an extrusion made to allow clearance for another sheet or extrusion. Joggles allow both the main portion of the material and the portion of the material over the sheet or the extrusion to lie flat. And final question before it starts to get into welding, which was my previous video. 8103. Shallow scratches in sheet metal may be repaired by burnishing. Their explanation is, shallow scratches in sheet metal may be repaired by burnishing. Burnishing is a process in which a smooth tool is used to force the raised material back into the scratch. And that's the end of the rivets. I did welding already because that's a test that I have next week, probably Thursday. So I'm making these for myself, but anyone is welcome to use them. If you have suggestions, if I need to change anything, I'm open to constructive criticism. Just don't be a jerk about it. That's all I ask. But anywho, that is the end of rivets on page 12 in the ASA test guide. Thank you for tuning into my channel. Thank you for watching the video. Like I said, if you have any suggestions or anything you want to say, or if you need help with something, I'd be more than happy to help you out. Yeah. Hope you guys have a great rest of your day or night, and I will see you all next time.